Hi ladies and gentlemen, this is Mr. Green and I'm sending you this recording for Algebra 1. This is a recording for the homework 4 that deals with inequalities and graphing inequalities and inequality systems. So wanted to make certain I cover a couple of things with you all. First of all, as far as a method goes, we've already learned three different ways of solving system of equalities. One method is to graph them. A second method is to use substitution, where you put one value in for the others and solve down to where you can find a value for the variable then. And the third type is elimination, where you would manipulate the equation so that you can eliminate a variable and solve for the other one. Okay, so those are the three techniques that we've got for solving system of equations. But when we're looking at system of inequations or inequalities, they're not equal to each other. So we need to go through a little bit of a process here and look at how we would do these. They're very similarly done. The first thing I'm going to tell you to do is to isolate the variables to one side of the inequality. In other words, I want the x's on one side and the y's on the other. So in this particular first one here, I'm going to move the x onto the other side over here. So I'm going to subtract 2x from both sides of the equation. That means that'll cancel out there, and I'll be left with negative 3y is less than, make sure you get the sign right, 12 minus 2x. Now I'm going to divide by the negative 3, because then what I'll have, I divided by negative, so my less than sign is going to turn around, and that means it'll be y greater than 4. 12 divided by negative 3 is a negative 4. And then negative 2 divided by negative 3 would be a positive 2 over 3x. Now what I've done is I've solved this down to being y equal to something. That's easy to make that substitution later on, isn't it? Well, let's look at this one. If I take this one and solve it down, x is on one side, y is on the other side. I'm going to subtract the x from both sides, and I'm going to get 5y is less than 20 minus x. I'm going to divide by the 5's. It's a positive number, so it's not going to change the sign any there. And I'll have y less than 20 divided by 5 is a 4. Okay? And then I have minus x over 5. And then I've got this one little thing down here. X is greater than 0. Well, you know what? I've got three equations. I can then graph them. And on inequalities, I think it's better to use the graphing approach in this situation. So the first thing I'm going to do is I'm going to graph that first one. See, 2/3 x minus 4. That's what I've got here, 2/3 x minus 4, right? And so what I've done is I went down here to negative 4. I went up 2 and over 3, up 2 and over 3. Got my line that I drew in there, and I'm going to be shading up on that side of the line to the north of it. Okay? So let's look at the next line. The next line is y is less than or equal to 1/5 x, or x over 5, plus 4. So I started at 4. I'm going to go up, down 1 over 5, down 1 over 5. That's the way you can do that. Look at that. Okay? And I'm shading on that side. So you can see I've got two different sides shaded here. One is the top side here and one is the bottom side here. Let's graph that third line, x greater than 0. That'd be on this side here. Essentially what I've got is all this area in here, don't I? All that area in there. That is my solution region. That means any point inside of that solution region would be an acceptable point, would be a solution to the problem. So I could pick 2, 2, 1, 2 over 2 right there. That would be a good solution to the problem. Okay? That's why I think it's easier to graph it, because then you can see all the potential points that could be solutions to this one, because they're all of these are valid answers to this particular question. Okay? That's why I think graphing works better for inequalities. So, let's look at this one. First of all, isolating the variables. So, I'm going to subtract the 2x from both sides, minus 2x, minus 2x. And what am I going to wind up with? I'm going to wind up with a minus y greater than negative 3 minus 2x. I'm going to divide by the negative 1, and I'm going to get y, reverse the sign because it reverses because it's a negative I'm dividing by, and it'll be a positive 3 plus 2x. Okay, doing the same thing for this one, minus 4x, minus 4x, and when I get that, I'll get y less than 5 minus 4x. Okay, that's the way you isolate the variables. Now it'd be real easy to graph this. Okay, so I don't have graph paper there, so let's put some graph paper up. Oops, hang on, don't do it that way. Go to the next page, put graph paper up on that page. I've done this before. Okay? Okay. Y less than 3 plus 2x. Well, I'm going to rewrite that one. Y less than 3 plus 2x. So I'm going to start at 3. 1, 2, 3. And it's a slope of 2. Go up 2 over 1. Up 2 over 1. Up 2 over 1. And I'm going to put that as a dashed line like this. Why is it a dashed line? Because it's a strictly less than. Okay? If I stick zeros in there, is 3 less greater than 0? No. So it's going to actually be this side of the line out here that we're shading. Okay? So let's go back and look at our equations. We got y is less than 5 minus 4x. So y is less than 5 minus 4x. So I'm going to go down here to, I'm going to go up here to 5. That was at 3, 4, 5. And I'm going to have minus 4. That means I go up or down 4. 1, 2, 3, 4 over 1. Down 4 over 1. And my dash line looks like this. Like that. Okay? So 0, 0, 0 less than 5. Yes, so I'd be shading on this side of it this way. And my actual answer is in this quadrant out here, isn't it? Because I've got this line going up like that, and I've got this line going down like that. So this area out here is going to be where my answer is. Anywhere out there. Okay? Hopefully you guys are seeing how that works. Another inequality here. Let's go through and solve it. I'm going to just add the y's to both sides. And what I get is x less than or equal to negative 2 plus y, and x is greater than or equal to 2 plus y. I'm going to add 2 to this side and subtract 2 from that one, plus 2. And I'm going to get x plus 2 is less than or equal to y, and x minus 2 is greater than or equal to y. Okay? So we want to graph those. Graph paper, please. There it goes. Coming back over here. X plus 2 less than or equal to y. So I write that down. X plus 2 is greater than or equal to y. Did I write that right? less than or equal to y. Less than or equal to y. Okay? So I'm going to start at 2, and I'm going to have a slope of 1, so it's going to go up. It's a solid line. It'll go like this. Okay? So you can use my line here. That. That. Okay? So is 0 or is 2 less than 0? No. I'll be shading on the north side of this one here, up here. Okay? So let's go back and look at our equations one more time. We've got x minus 2 greater than or equal to y. X minus 2 greater than or equal to y. Well, that's starting down here at negative 2, and I've got a slope of 1. So let's see here. Make certain I get my line in the right place. And it's like this. And when I put 0 in there, I get negative 2 greater than 0, and the answer is no. And so I'll be shading on this side down here. Look at this. My slopes are actually the same, aren't they? I got a slope of 1. So these two lines are never going to intersect each other. Their graphs don't overlap each other at all. So there is no solution for this one. There's no solution set, no solution area. Okay? So let's move on. Here's a word problem. It says, we sell CDs. A website plans to purchase ads in their local newspaper advertising to advertise their site. Their operating budget will allow them to spend at most $2,200 on this advertising adventure. They plan to run at most 20 ads. When I see at most, that tells me that we can write it as inequalities. Okay? They're going to have an ad that will cost $50 to appear in the weekday paper and $200 to appear in the weekend edition. So I'm going to say X equals weekday and Y equals weekend. Then what we can say is that X plus Y has to be at most less than or equal to 20, and their cost, we would say 50x plus 200y at most has to be less than or equal to 2,200. Can you see how I'm getting these words and they're helping me know which way I'm writing my inequalities and what my inequalities need to look like? Now it's a factor of solving these down and getting them as something that I can graph. And so this one would be y is less than or equal to 20 minus x. And this one over here is going to be, let's see here, first step will be 200y less than or equal to 2,200 minus 50x. And we divide by 200. What we'll get is that y is less than or equal to 11. Yeah, 11 minus 50 over 200 is 1/4. 1/4 x. Those are the two lines I need to graph. Okay, so let's put let's put a new page in here and put a piece of graph paper up there. Okay, and my equations were y less than or equal to 20 minus x, y less than or equal to 20 minus x. So that means I'm going to go to positive 20 up here. 5, 10, 15, 20 is off the top of my page, and it's got a -1 slope. So that's here, it'll be right about here. And it's going to be a solid line going down like this. let's see here. If I put 0 in there, I've got 0 is less than 20, and that's true. And so uh, I would be shading on this side of the line this way. Okay? The other one is y is less than or equal to 11 minus 1/4 x. Y less than or equal to 11 minus 1/4 x. So I'm going to start at 11, and I'm going to go down 1 over 4, 4, down 1 over 4, 1, 2, 3, 4. And I would draw my line from there. Didn't do that very well, sorry. Try that again. There it goes. That's what the line would look like. And if I stick 0 in there, 0, 0, this point here, 0, 0, I get 0 is less than 11, less than or equal to 11. That's true. And so I'd be shading on this side of it down here. And you can see my common area that I would be looking for in this situation would be this area down here, like that. That would be the common shade area in there. Any of the points in here would be valid points. Okay? So what would I be looking at? Well, remember what I had as X and Y. X was the number of ads that I would place in the weekday paper. Y would be the number of ads I'd place in the weekend papers. Okay? So I'd have anything from 0 to 11 on the weekend papers, and from 10, 19 up to 19 in the weekday papers. That would be the area that I'd be looking at. Any combination of that, and I'd be underneath the 2200 budget line that I'd be looking for. Cool? Okay. Just to show you that this is not something that's totally unusual, when you go to take the STAR test, you will be having to look at some questions like this. This one says there are 9 books stacked on a shelf. The thickness of each book is either 1 or 2 inches. The height of the stack of books is at least 14 inches. That means we've got to have something that is greater than or equal to 14. Which system of equations to determine X, the number of books that are 1 inch thick in the stack, and Y, the number of 2 inch thick books? So what you've got is X plus 2Y has to be greater than or equal to 14, and that X plus Y has to be, there are 9 books, so it's going to be equal to 9. So looking at these, we're not, that one's not going to work. We don't want X plus Y of 14. We don't want that one. We want, well, that one has the right numbers in it, and so does this one, but it's X plus 2Y greater than 14, greater than or equal to 14. That'd be the one I would pick right there. Okay, I said greater than or equal to, oops, didn't circle. I said greater than or equal to because it said is at least, but it could just be greater than. Okay, moving to the next one here. Another STAR question. What is the value of X in the solution to the system of equations below? And this is basically just a system of equations. I want to show this one with elimination because I think elimination works easily here. So I've got 6x plus 3y equals 13. And if I multiply this one by 2, I'm going to get 6x minus 2y equals 8. Now if I subtract this whole thing from the one above it, I'm going to get 5y equals 5, or y equals 1. Now that I've got y is equal to 1, I can go back and substitute it into either one of these equations, and I would have 6x plus 3 equals 13. Subtracting the 3, 6x equals 10. X equals 10 over 6, or 5 over 3. Okay? Now, going back and reading the equation, what's the value of x? 5 over 3. That would be this one right here. I hope you see how I did that elimination. I mean, that's one of the ones that one of the techniques that is used to get these to solve a system of equations. Okay? So, Tuesday, we have my class connect, 11 to 12 o'clock. Make certain that we're going to be getting close to the end of Unit 6 and starting Unit 7 next week. So make certain you bring everything you need to Class Connect with you. And I'll look forward to seeing you then. Bye.